Good evening, Chem students. This set of notes is about 3-2 notes. This is the combined gas law. We talked about this on Friday. So we are talking about the empirical gas laws. So starting off, an important piece of information is STP. STP stands for standard temperature and pressure. Standard temperature and pressure. And those conditions are 1 atm of pressure at 0 degrees Celsius. That is important to remember. You will use it in problems throughout the rest of this chapter. All right, so rolling on. In the lab on either Wednesday or Thursday, we talked about Boyle's law and we learned the relationship between pressure and volume. We found that as pressure went up, volume went down, and vice versa, or we could say that that is an inverse relationship. So the formula that we have there is P1V1 equals P2V2. So very simply, 1 and 2 are just conditions or times of conditions. You could also think of it as P initial times V initial equals P final, V final. So moving on to Charles's law. Charles's law is the relationship between temperature and volume. And Charles's law says that as temperature goes up, volume also goes up, and vice versa. So this is a direct relationship. And this is one where an example would be if you have a hot air balloon. All right, you heat up the air, the volume of the air goes up. Very simple. So the formula for this one is V1 over T1 equals V2 over T2. Very simple as well. That's an example of a direct relationship. And finishing it off, one other thing that we need to note, anytime we are using temperatures, they must be in Kelvin. Be in Kelvin. We are going to have to convert all of our temperature to Kelvin. So that's all well and good, and it's really easy, but right now we have two different formulas, and there's another guy, Gay-Lussac, that we could talk about his, but instead we're given what is called a combined gas law, and that's where we're going to combine both Charles's law and Boyle's law. So here's Boyle's law, P1V1 equals P2V2, and then for Charles's law, we said it was V1 over T1 equals V2 over T2. Well, this right here is the combined gas law. And most people, that's actually the formula that we use. I am not a fan of fractions, so I'm going to multiply to get the fractions out and leave me with P1V1 T2 equals P2V2 T1. And the key here is to remember temps need to be in Kelvin. And the other thing is, this is the only one we have to memorize. So if one unit is constant, we can just cross it out. All right, so we can cross it out, if that makes sense. So let's use that formula right down here on our first example. So I'm going to write P1V1 T2 equals P2V2 T1. And if we take a look at here, we've got a 48.3 milliliter sample of a gas in a cylinder is warmed from 22 degrees C to 87 degrees C. What is the final volume? So if we look there, milliliters is a volume. So it's the first volume I see. So I'm going to assign that V1. V1 is equal to 48.3 ml. I keep reading. 22 degrees C, that's a temperature. That's the first temperature I see, so I'm calling that T1, 22 degrees C. On to 87 degrees C, T2, that's the second temperature I see, so 87 degrees C. What is the final volume? V2 is my question mark. And as you can see here, we have nothing about pressure, so we can just lose P1 and P2. And we're left with what is Charles's law, but we can still start with the combined gas law and use Charles's law. So before we start plugging things in, we need to know that we're at degree C, and we have to convert our temperatures to Kelvin. So we're going to add 273.15 to each of these, and that will give me my temperature in Kelvin. So that's going to be 295.15. And then we've got 87 plus 273.15. And we're going to come up with 360.15, and both of those are Kelvin. So we've got V1, which is, and now we're just ready to plug them in. So 48.3 is V1 times T2, which is 360.15, equals V2, which is what we're looking for, times T1, 295.15. So we're ready to solve, and basically to solve, we've got to isolate V2, so we're going to divide each side by 295.15. Now, as you can see, it cancels on this side, and we're left with V2 equals 48.3 times 360.15 over 295.15. So 48.3 times 360.15, and then divide by 295.15, and our answer should come out to be 58.9 ml, and that's our second volume. Pretty simple, right? These are all going to be plug and chug formulas for us, so it should be pretty simple to use. So let's move on to this next example. Says a 9-liter air sample has a pressure of 117 kPa at a temperature of negative 25 degrees C. If the temperature is raised to 107 degrees C and the volume expands to 17 liters, what will the new pressure be in ATM? So we're going to start with the combined gas law, P1 V1 T2 equals P2 V2 T1. And I'm just going to go through and write, well, 9 liters is a volume. 117 kPa, that's a pressure. This is the first temperature I see. Temperature is raised to, that's T2, and 17 liters is V2, and we're looking for P2. So as we write, V1 is 9.00 liters, P1 is 117 kPa, T1 is negative 25 degrees C, P2 is what we're looking for, and we're looking for it in atmospheres. V2 is 17.00 liters, and T2 is 107 degrees C. So again, before we can go any further, we have to convert our temperatures to Kelvin. So we're going to add 273.15 to each of these. And for that first one, we're going to get 248.15. And for the second one, we're going to get 380.15. Now, one other way to solve these problems is, since we're looking for P2, we could isolate P2 in the formula before we even plug anything in. And so notice I'm going to divide each side by V2 T1. That way it cancels, and we're left with P2 equals P1 V1 T2 over V2 T1. And so we can just plug it in. P1 is 117 times V1, which is 9 liters, times T2, 380.15, over V2, which is 17. And then we're going to times that by 248.15. And now all we have to do is plug it in our calculator. P2 will be equal to 117 times 9 times 380.15 divide that by 17, and then divide that by 248.15. So this will give us a pressure of 94.9, but that's in kPa. And unfortunately, we're not quite done because this problem asks us to take the pressure to ATM. So we have to do one more step. So we'll change colors here. We know that 101.325 kPa is equal to 1 ATM. So if we divide 94.9 divided by 101.325, that'll tell us how many atmospheres we have. And that should give us P2 in atmospheres, which is going to be 0.936, 0.936 ATM. And there you have it. Thanks. See you next time.